Hello and welcome to Lesson 11 of the UNIDO SPX programme, Maintenance, Keeping Things Going. In this lesson we will talk about why maintenance is important, 5 types of maintenance, organisation structures for maintenance, skills development, and about a plant register and associated tools. Why is maintenance important? To produce effectively, machines and processes need to be available. It seems very obvious, but to be competitive, to be efficient, to build your capacity, your machines need to be able to do what they are supposed to do when they are supposed to do it. To achieve this, they must work and work well when they are needed. It is easier to fix before something breaks than afterwards. If you take the simple example of your bicycle, it is often easier to adjust the tension of the drive chain before it gets caught in the wheel than it is afterwards. It's certainly less messy. The same idea applies into industry. If we can adjust our machinery and keep it running properly before it breaks down, we can be more effective and efficient and spend less time trying to fix problems as opposed to making sure they don't happen in the first instance. Adjusting is always cheaper than replacing. If it's possible to adjust small increments, small adjustments to a machine or a process or a piece of equipment, it is much cheaper than buying new parts, often difficult to get parts. So it's much easier to adjust than to replace. Also, learning about machines and processes can help develop them to achieve more. Most machines are built by machine makers. Very few of these machine makers have the experience of running machines in a production environment. As you and your team build your capacity and your ability and your understanding, it's quite possible that you will find ways to improve the machinery that you have to make it better than that delivered to you by the machine maker, because you will have increased your understanding of how the machine should work as opposed to how it was designed. The only way to achieve this, however, is about learning about your machinery and trying to understand its concepts and its basic fundamental structures. Life cycle without maintenance. In this graphic, we describe the normal shape of the life cycle of a piece of equipment. Engineers call this the bathtub graph. The yellow curve describes the performance of the machine over its life cycle. At the early stages of its life, there is a high probability of failure. When a machine is being installed, it is not always running properly, and many faults happen in the early stages of its life. When these problems have been fixed, we move into what we call the normal operation, where the machine performs within acceptable standards. Towards the end of its life, as the machine wears out, typically we find more failures. As the machine becomes less reliable, more problems happen, more parts begin to break or wear out, and failures occur. This happens between the early life and the end of the life of the machine. With a concept called total productive maintenance, basically the use of good maintenance practices, we can reduce the probability of failure over time. And in our next graphic, we will describe this. Once again, we may have the situation of early stages of failure, high levels of probability of failure in the early stages of life of the machine or the equipment. We will move into the normal operation, but with good maintenance, it becomes possible to extend the life of the machine and the equipment at a greater degree. We call this the life cycle of the machine with maintenance. On my first visit to Japan many years ago, I visited a company called Nissan Diesel, and I was surprised to see in their machining halls very many machines that I recognized from my early days in university. The only difference with these old machines were that they had been equipped with new measurement equipment and simple devices to allow the machines to run more effectively and efficiently with less input from the workforce. So in actual fact, this company in Japan had found a way to extend the life of their machinery, plus also to improve its capability, because they had taken the time and the effort to develop their understanding of the machinery, as well as the concepts, as well as the possibility of making simple adjustments and additions which extended the life and the efficiency of the machinery. There are some key principles of good maintenance. The first of these is cleaning. If an environment is dirty, it is hard to see where a problem may be arising in a machine. If a machine is leaking into a dirty environment, it is very hard to identify the source of the leak. If it's leaking, it's not operating the way it is supposed to operate. So if we can start our proper maintenance journey by cleaning our environment, by cleaning the machinery, by cleaning the space around the machinery, we begin to get an understanding of our machines. We begin to get an opportunity to identify when something is going wrong, before it goes wrong, before it fails. This in turn helps us to adjust rather than having to replace or fix something that is broken. A key part of the cleaning and the organizing of an operation is this fact of organizing. There is a phrase in English called everything in its place and a place for everything. Why do we want to have an organized workforce, an organized workplace, an organized machine? It's so that we can find what we are looking for when we need it quickly. If something is disorganized, we may waste time looking for pieces of equipment, looking for tools, or looking for spare parts. If the place is organized, we can find the spare parts quickly and the correct tool and even the correct information to allow us to be able to get the machinery running again quickly and efficiently. Caring. Caring, I believe, is very important for a maintenance team, for an engineering team in a business. It becomes very obvious very quickly if you walk into a factory, if the people care for their environment, if they care for their equipment, if they care for each other, if they actually care if the business is successful or not. It's important to care about the machinery. If we overload a machine, if we don't maintain it properly, if we don't take care of its lubrication needs, the chances are very strong that the machine will fail, that it will break down. If, however, we care for the machine, the chance that the machine will operate well and consistently is much higher. So caring is a very important aspect, and I will deal with this later on in this lesson. But we must understand our machines. We must understand the principles of operation, the point of process, how the machine takes a raw material and changes it into a part or a component or a product. If we don't understand the basic laws of physics, the basic laws of mechanics that control the machine, it will be very difficult for us to maintain it, to run it, or even to improve it. We must work to understand. Doing. When we do something, when we see an opportunity to improve a machine, to maintain it, to take care of it, to organize around it, unless we do something to change the state of the machine, to change the state of the environment, it will just stay the same. And there should be a dynamic in a maintenance team, in an engineering department, to want to do, to want to improve, to want to understand, to want to take care, and to want to maintain the optimum level of performance of their equipment. 5 types of maintenance. 5 key types of maintenance have been identified and defined in engineering as we know it today. The first of these is fixed time maintenance. It deals with time-based activities that will be dealt with to deliver improved performance of a machine. The second is a concept called operate to failure. In this environment, the machine is run until it breaks down. The third type is opportunity maintenance. Sometimes a machine will fail, and sometimes the opportunity will be taken to replace other parts that may not have failed yet, but would be approaching their life end, given the fact that the machine is opened for work to be done on it. The fourth type is called condition-based maintenance. Based on how the machine is performing, certain activities and actions can be done to improve the overall performance and life cycle of the machine. The fifth key type is that of design-out maintenance. As the name suggests, it relates to designing maintenance out of the cycle of the machine's operations. We will deal with these 5 types of maintenance in some detail during this lesson. The first of these types of maintenance is fixed time maintenance. We would understand that with our cars, with our motorcycles. We would replace the oil, the spark plugs, the filters at a fixed time or a fixed distance. Annual services. We understand the concept that a vehicle gets serviced annually. Oil gets replaced every 6 months or after a certain mileage. And on this basis, if we take it into our manufacturing environment, we might do an annual maintenance of a machine. We will have certain activities that will be done to the machinery or the equipment every year on an annual shutdown. It's very normal in process industry or in the food sector. So the machine gets certain items changed, adjusted, replaced on a time-based level. In an operate to failure environment, it's typically used in a situation where many simple pieces of equipment can be replaced quickly. Imagine the picture of a sewing machine. In a sewing factory, the machine is simple, small and light and can be replaced very quickly. And typically, a sewing factory will have a number of reserve machines that can be put into place if a machine breaks down. The broken machine is taken aside, is repaired, is brought back to operating condition, but the operator, the sewing person, has a new machine to work with, a replaced machine to work forward with. If you imagine the same situation with your car, it is unlikely that you would replace a drive shaft at a particular distance or at a particular time. You would most likely drive the car until the drive shaft failed, until you began to be aware that the drive shaft was going to fail in service. In that instance, you would replace it because it had failed. The third level is what we call opportunity maintenance. If you imagine a situation here that sometimes a part needs to be replaced because it is broken, sometimes a part has gone to the end of its life, and imagine an engine being rebuilt. You may take the opportunity when you're rebuilding the engine to also replace the pistons, to check the crankshaft, to replace shell bearings, to check the head and do the valves. Because you have the engine removed from the car, there are probably many other tasks or checks that you may choose to take on because you already have removed the engine from the car. You're taking the opportunity to do these other jobs when the engine is removed and disassembled. If you take the same example into industry, if you're working on a significant machine on its annual changeover, you may decide to do a number of different checks at that time. You're taking the opportunity to do additional work because the machine is available to you and has been disassembled. The fourth type of maintenance is called condition-based maintenance. And in this type of maintenance, it talks about the condition of the machinery. You're moving into a reasonably sophisticated environment. You'll begin to look for sound and vibrations and emissions, for temperature, vibration and lubricant. You begin to try to understand what is the optimal performance level for the machine. In the simplest of terms, if you watch good engineers walking through a factory, you will often see them use the tips of their fingers to put it on the frame of a machine to feel for vibrations. Half the time they don't even know that they're actually doing it. But you will notice good, capable maintenance and engineering staff walking through a production environment, listening for strange noises, checking the vibrations on machines, being aware of changes in temperature as they walk past machines. They actually care about their equipment, they've actually come to know and to understand it, and they are sensitive to changes. Many years ago, I was working with Nestlé on a sweet making machine, bonbons. And the ladies who worked on that machine every day could tell me as the engineer that there were issues arising in the machine long before we as the engineering team would have become aware of it. Because they were aware of changes in the sound or the vibration or the smell or the feel of the machine. And it's very important to be aware and to be open to your people working in the factory to be able to share with you things that they may say. They may not know exactly what the technical term is or the technical issue with the machine, but they might well be able to help you identify a leak, a noise, a corrosion, or some other aspect of change in the machine that would give you, the maintenance engineering team, the opportunity to adjust the machine before it breaks. When you're talking about condition-based maintenance, it's important to keep records. The informal checking for the vibration is interesting. To have a situation in place where you can actually keep records of temperature or vibration or sound levels over time moves into a different level of sophistication. 7 years ago, I had a chance to visit Harley-Davidson in their engine manufacturing facility. And we had a tour from the production manager, and we talked about many different things. During the time, he talked about their condition-based maintenance activity. They had started a process of putting sensors on their major machining tools to identify changes in vibration or temperature. It was costing a lot of money per machine to put on this level of sensors. During the course of our discussion, I mentioned to him the possibility of not putting sensors on the machines, but identifying places on the machines where measurements could be taken. And if you were to take this idea into your own manufacturing environment, maybe you can identify bearings, cutting surfaces, places on your machines where it's possible to buy one thermometer, one vibration meter, one sound meter for small amounts of money, and to be able to record the facts from your machines over an extended period by bringing your temperature sensor, your vibration meter, your sound meter to particular places on the machine and recording the measures over time. As your records build up, you will begin to see changes in the vibration levels on the machine, the temperatures, the bearing noises, and that in turn, the change can give you an indication in advance that the machine is moving to a difficult situation or is running in a very capable situation. But condition-based maintenance, it can be quite sophisticated or can be very simple down to the engineering and maintenance staff checking with the tips of their fingers for changes in vibration in key pieces of equipment. Design out maintenance. The fifth type of maintenance refers to designing out maintenance. This can only be done as you gain knowledge of your machine and your process. I referred earlier to the point that machine makers do not usually have much experience in running machines, whereas us who work in a production environment have a lot of experience on the day-to-day use of the machines and how they operate within a manufacturing environment. As we gain knowledge of our machines and our processes, we maybe find things that break on a regular basis. If we can communicate with our machine makers, we can maybe give them information so that they can design out those problems in the next iteration of the machine. If we have the skill and the ability and we have the resources within our own operation or a local supplier of parts and components, we may be possible for us to create pieces of equipment, replacement parts that will be stronger or more able or more capable than those supplied by the original machine maker. It's only possible for us to do that if we gain knowledge of our machine and our process. But that in turn gives us the opportunity to develop fixes. And this in turn gives us the opportunity to improve the performance of our plant, our equipment, and our effectiveness and our competitiveness, while building the capacity not only of our equipment, but most importantly of our people, our engineering, our maintenance people, or our local supply base. And this development of fixes can give us a very significant opportunity to have potentially a strategic advantage over other companies who choose only to keep the machines and to run the machines as delivered by their makers. As we build this knowledge, we get the opportunity to build in solutions. We will certainly know more than the people who design the machines. The potential actually could arise where it becomes possible for you to share your idea with the maker of the machine, or even to sell the concept, the idea, to the maker of the machine. But it all comes from a basis of knowing your machines, understanding your processes, and building your capability to run the machines effectively and efficiently. We will now talk about organisation structures and how to organise your people in the maintenance and engineering areas. Some businesses operate in what's called a single skill environment, where a maintenance manager will have individuals who are focused in buildings engineering, mechanical engineering, electrical engineering. And this is a traditional way to organise the team in a maintenance function, where people have a single skill and focus on a single given area. However, an evolution has taken place towards a multi-skilled response to maintenance and engineering. And in this environment, the maintenance manager is still responsible for the maintenance and the engineering within the facility. But he has moved to a slightly different approach. There would be a maintenance foreman who would have some multi-trade skills, people who are capable of handling the modern machinery that includes mechanical, electrical, hydraulics, electronics, pneumatics. But they build up a multi-skilled group of people who will deal with the day-to-day running and maintenance of the operations. In the multi-skilled environment, there's typically usually a preventative maintenance team also created. This team looks at the daily work of the multi-skilled team, but are looking to see how the equipment and the processes can be improved to prevent failures, to prevent reduction in performance, to improve the outputs and the capacities of the equipment and the plant. And a planning engineer will work with the two key teams, working with the maintenance manager to develop a coherent plan so that the machines can be maintained, upgraded and developed within the requirement to deliver the capacity and the outputs of the manufacturing facility. The multi-skilled approach is becoming more current because of the complexity of equipment and machinery, and also because of the benefits of being able to understand the full process, the full equipment, and the full interaction of electronics, electrical, hydraulical, and mechanical systems within manufacturing. Skills development. Skills development is very important because of the changing and evolving nature of the equipment that is now being used in manufacturing, because of the increasing level of technology involved in manufacturing, and also because of the increasing demands of customers on suppliers. We need to identify our current skills levels. If we want to develop the skills of our people, we must understand what our current position is. We also need to be clearly able to identify the required skills level. What level of skills do our team need to have into the future? We obviously need then to plan to fill the gaps. If we know what our current level of skills are, and we've identified what the future skill requirements are, what we need people to have, we need to plan to fill the gaps. Given the changes and the evolution of machinery and equipment and processes, the gaps will continually arise. Static machinery is no longer the norm in industry. New machines are coming with new systems, new capabilities, and the gap will always be there. We need to plan to fill the gap. We're suggesting the use of a 4-box system called the Skills Matrix. Further detail is presented in the support materials going along with this course. But it's important as the management team, the leadership team, that we implement and monitor our training plan, that we develop the skills of our team so that we can actually drive forward and ensure that our people do build their skills, do build their capability, and are in a position to deliver the proper level of maintenance and support to our manufacturing environments. We, as managers and leaders, must take responsibility to implement and to monitor. We must ensure that our people are given the opportunity to drive forward, and they must be given the challenge, and the expectation must be set that our team of people will take on this opportunity and this challenge. The support materials will present you with the 4-box system to allow you to identify how to build your people and what skills they need. But in short summary, down one side of the page will be the people, across the top will be the skills they need, whether it be mechanical, electrical, hydraulic, pneumatic skills. The skills will be dependent on you and your business, you and your machinery, you and your process. So it's up to you to identify what the skills are, but it's also up to you to identify who your people are and how capable they are to deliver on the requirements of your business. Plant register and associated tools. What is a plant register? A plant register is a list of all the plant and equipment that are in your facility. Once again, it sounds like a very simple idea. But do you have a list of all the plant and the equipment that you have in your factory, in your business? A lot of businesses do not have this list. They do not have a means and a mechanism to record the activity on each of the key pieces of equipment. Why is this important? Maybe your staff are constantly fixing one piece of equipment. And maybe you as the manager or the leader are not aware of this. And maybe that piece of equipment is absorbing a lot of time and effort and energy and cost, and actually reducing your ability as a business to deliver value to your customer. The plant register should capture the maintenance input, should capture the amount of work, the amount of parts, the amount of effort that is being given to that particular piece of equipment over a period of time, so that you in the management role can decide if there is a requirement to actually replace or significantly improve the performance of that machine. It should capture the breakdown information. It should be looking to see how often and for what level of time the equipment has broken down or has given reduced performance to the manufacturing staff. With this information, we in the maintenance area can find ways to give better service to our customers, who are the production staff. And to be honest, we should be integrated into the production team so that we can support them to deliver to our customers' needs. We are looking to identify where problems are and how much they are costing. Quite often it's difficult to remember what happened last week or last month without having captured these types of records. If at the end of the year we are trying to decide our budgets or trying to plan for next year, without having the facts and the information of where our problems arose, where our breakdowns occurred, where our spend in terms of spare parts and availability of time of our maintenance team was spent, we are guessing. And in actual fact, the plant register can help us to have facts to help us make the right decisions. We are, throughout the UNIDO SPX system, looking to capture facts so that we can deliver better value to our customers, but also retain more value into our businesses themselves. To help us capture the facts in a clear and coherent way, we would suggest to you the use of what we call the measles diagram. The measles diagram. What is the measles diagram? It's a support to the plant register. We would suggest that you draw an outline of your factory, of your offices. And on the outline, draw in the key pieces of equipment. It does not have to be a detailed drawing. A simple block diagram can be used. And each time a piece of equipment has a problem, put a simple dot onto the page. We would suggest using a red pen, simply for the fact that it highlights there is a problem at that particular point. Over a period of time, a week, a month, a quarter, a year, you will see a series of measles, the dots, appearing across your facility. The big question comes then is, what are you going to do to fix these problems, to take care of these measles? The system provides a visualization of where the issues are arising. The measles show you where the problems are. It can be used at plant level analysis, where you have the outline of your full factory. And you can see then in the factory which pieces of equipment are causing you the biggest problems. When you move to fix the problems, obviously you have to prioritize which pieces of equipment you're going to work on with your team first. But the measles give you a very good indicator of where you should be focusing next and where your priorities will go to in level 2 and level 3. But the measles diagram can equally be used at machine level for analysis on complicated machines and processes. In many processing plants, our equipment is not simple. It can be difficult to identify which part of the machine if the record only shows the machine had stopped. Draw a simple diagram of the machine. Give this to your operator. Ask the operator or the maintenance team to put a dot, the measle, on the sketch of the equipment to show where the problem was. Over time, this dot, this measle, can help you identify where you need to fix, where you need to focus. At the plant level, it's clear. It may need capital equipment. It may need to replace a machine. It may need to change the process. At the machine level, it may mean a part needs to be replaced or a part needs to be designed so that it will not break down going into the future. The system initially was used back in the days of war, where they would look at and analyze aircraft returning from conflict. They would identify where the holes were on the simple diagram of a plane. The question was, where would they armour the plane? They chose not to armour where a plane had come back and there was a hole. They quickly identified that they needed to armour particular parts of the plane so that the plane returned home. I have used this system myself in many complicated machines, in many industries, and it has proven very helpful to both the operators who did not know the technical details of equipment or machinery, but also to the maintenance staff and the engineering staff to be able to capture a visual representation of where the issues were and where the challenges were, so that they could find ways and solutions to improve the process, to improve the machine, to increase its availability to the manufacturing staff so that more products could be made more effectively and efficiently, increasing capacity. We move on to talk about operator maintenance. In many instances, the maintenance and engineering team in an operation is small. But we have typically more operators than we have maintenance staff. And to me, the significant opportunity arises in engaging the operators so that they can understand what we are trying to achieve as the maintenance and engineering team. To engage the operators, we need to teach them the basics of maintenance. I mentioned the ladies in Nestlé on the Bon Bon machine, able to identify problems on the machine without understanding the technical terms or the technical fixes for the machines. If we could teach them some of the basics of maintenance, which we did, they were able to identify and do things which released time for the maintenance team to do more challenging and difficult things. We helped them to know what to watch out for. In addition to the things that they were aware of, we were able to teach them certain things that they could give us early warning, that we could make an adjustment long before the machine hit a problem. By engaging with the operator, it lets them assist us and free up the maintenance team to do more and better work. We have trained and skilled maintenance staff, engineering staff. If we can have our operators do some of the basic levels of maintenance, it means that our skilled staff can do more challenging and advanced things. Maybe they can find answers and solutions to problems that have always been a difficulty for the manufacturing team. Maybe they can create issues, create solutions, create opportunities to make the work easier for the operators. Quite often, the opportunity is there for the fitting staff, the maintenance engineering staff, to make the simplest of pieces of tools, holders, positioning systems that makes life so much easier for the operating staff. To make materials presented to them in the right place at the right time with the least amount of effort. But also, it can often free our maintenance and engineering teams to be able to think about solutions to create pieces of equipment that can do jobs more effectively and efficiently. In my own experience in Nestlé, as we fixed our day-to-day maintenance problems, we were able to use the resources of our engineering team to create new equipment. We developed pieces of equipment that could automatically make food. It sounds strange, but we actually brought simple pieces of equipment together, which meant that we were able to create a mayonnaise making machine that had not existed before we tried to make it. In this way, it's possible to improve the capacity of your business by creating space and time for your maintenance and engineering staff to do things better. In all things, in this whole space, it really is about working as a team, about finding opportunities for the maintenance team to work with the maintenance manager, the engineering team to work with the maintenance people to work with the operators, the people who are responsible for producing the products, so that they can actually find ways to make their life easier and more productive, so that the operators can work with the maintenance team to identify issues on the equipment and the machinery before they become a significant problem. To make the adjustment is much easier than to repair the machine. To keep the machine running is much better than having to stop it and to restart it. One of the main challenges facing maintenance and engineering teams, I would suggest, is how to take a standard piece of equipment and to make it better. The only way we can do that is if we understand how it works and how it should work normally, and then understand how we can make it better, how we can improve it. But very much to deliver on this concept requires working as a team in a business. But the business actually works in a broader extent too. And in the UNIDO SPX system, we talk about partnerships quite a lot. Quite often you may find that your customer has experience in using similar equipment over a longer period of time than you may have had. And the opportunity for the maintenance and engineering teams to talk to each other between your customer and your company can be very helpful. Similarly, it can be very helpful for your maintenance team to develop a relationship with your key equipment suppliers, and most definitely with local expertise in engineering, in support areas where they can help you and your team respond quickly, effectively and efficiently to ensure the optimum performance of your equipment within your business. It seems an extremely simple thing to say, but it's a very important point to make. The key role of maintenance and engineering staff is not to fix machines, but it's to help the production people deliver effective, efficient, capable, high-quality products to your customers on time, every time. To be a firefighter is interesting. to be able to develop machinery and equipment while the processes run consistently is a much better target and objective. Thank you for your attention.